Hi guys, today we're going to be reviewing solving systems of linear equations. For us this is 1.2, second section, still in that review period, or for others, maybe kind of new to you. That was that, and I hope it helped, and have a good day. Alright, so when we solve a system of equations, what we're looking for, and that doesn't have to be a linear, but we're finding the values for x and y that satisfy both equations. When we're graphing, the solution to a system of equations on a graph is where those two graphs intersect. In this case, we're dealing with lines, so I'm just going to write where the lines cross. And more mathematically, intersect is the word we want. More technically, or whatever we want to call it. To do a quick review of the y equals mx plus b form, for those of you who maybe haven't done it in a while or just don't remember it well, the value that is with x, the m there, that's your slope. And that's going to tell you how much to go up or down, depending on whether it's positive, you'll go up, negative, you'll go down, and then over to the right. So rise over run. B value, that is our y-intercept. And I spelled that wrong. Better. Okay, so y-intercept is going to always start on this axis. This is your y-axis. Whenever you're graphing a line, or almost always, but definitely if you're in y equals mx plus b form, you're going to start on that line. So the first one, 1/2 x minus 5, your y-intercept is negative 5. So you're going to start down here, and you have a slope of 1/2. That means you're going to go up 1 and over 2 and make your next point. You'll do it again, up 1 over 2, up 1 over 2. I'm going to go ahead and erase those so that it's not so messy, but I wanted you to see that pattern. Alright, so we start at negative 5, up 1 over 2, 1 over 2, up 1 over 2. I can also, to fill in the rest of it, go down and back to get the other side of the graph, because we do need this line to go all the way across the graph. Alright. The other line, I'll go ahead and do in blue. I have a y-intercept of 2 and a slope of negative 3. So I'm going to go down 3. Anytime we have a whole number, we can basically put that over 1. Down 3 to the right 1. Because it's negative, that's why I'm going down. Down 3 over 1, down 3 over 1. Again, I'll go ahead and erase that part. And then to backfill, back 1, or sorry, up 1 and back. I said up 1. Up 3 and back 1. Because you always want your line to go clear across your graph so you can see. Sometimes if you don't go all the way across, you don't hit your solution. And our solution is where they cross. So this point right here. So we're at 2, negative 4. So our solution is 2, negative 4. That's graphing. Another method we have is substitution. That's best if we have one or both equations solved for x or y. So solved for a variable. Set that down there. Alright, so Step 1 is to substitute the expression from the y equals or x equals equation into the other equation and solve. So what we mean by that is I have y and I have y. If I'm looking for the place where those two are equal, then I can assume those y's are equal. So in this first equation, I know that y equals 8x plus 10. So then what I have going on here is this y is equal to 8x plus 10, which is also equal to that y. So what I'm going to do is I'm going to take these two and swap them out. So I'm going to rewrite my equation, my second equation, this one right here, negative 4x minus 3. And then instead of that y, I'm going to put the 8x plus 10. And then I need the rest of that equation equals negative 16. Then I'm going to go into my normal solving steps to solve that. So I'm going to drop down the negative 4x. I'm going to distribute this negative 3. Make sure you know that that's minus 3 there. That's the whole thing you're distributing. So minus 24x minus 30 equals negative 16. Combine like terms. Negative 28x minus 30 equals negative 16. Add 30. Negative 28x equals 14. Divide by negative 28. I've got x equals negative 0.5 or negative 1/2. I'm going to go ahead and leave it as a fraction because that's kind of what I do. Step 2, up here, substitute back to find the other variable. So I'm going to take my first equation. You can use either equation for this, but I'm going to take the first equation and I'm going to substitute my x value, negative 1/2, into the x. So y equals 8 times negative 1/2 plus 10. And then just simplify. Negative 8 times negative 1/2 is negative 4, because it's the same as dividing by 2. Plus 10. Drop down that y equals just for good measure. And then y equals 6. I'm going to show you this just the one time. You can also check by putting both both values, 6 and negative 1/2, into that second equation. So I would put negative 4, my x value of negative 1/2, minus 3 times my y value of 6. And that should equal negative 16. So negative 4 times negative 1/2 is a positive 2. Negative 3 times 6 is negative 18. So I have 2 minus 18 equals negative 16, and that is true. So checked my point of intersection then, and my solution is negative 1/2, 6. So that's the substitution method when I've got a y equals or an x equals or whatever variable you're using at the time. Equal values method is kind of taught separately often, but it's really just substitution. It's best to use when both variables are solved, or both equations are solved for the same variable. You do want to make sure it's the same variable. If you have an x equals and a y equals, equal values method doesn't work. So step 1 says set the two equations equal to each other and solve for x or y. So here it's the same deal as we had before. We've got a y and a y. So y equals 9x minus 4. So if I have this y equals 9x minus 4, and that y is equal to that y, then basically I can swap these two things out again. So it's just substitution with a different name. So instead of having y equals 6x plus 17, I'm going to have 9x minus 4 equals 6x plus 17. And then I'm going to do my solving steps to solve for x. So subtract 6x from both sides, add 4 to both sides. So I've got those two cancel out, not cancel, but add out to 0. Left here I've got 3x, drop down my equal sign, those two add out to 0, equals 21. Divide by 3, so I have x equals 7. Then I can pick either equation. Y equals 9, I'm going to use the first one. So right here, instead of the x, I'm going to put 7 minus 4. So y equals 63 minus 4. So y equals 59. So my point of intersection here, 7, 59. Last one is the elimination method, also known as combination or addition. Best to use when neither equation is solved for x or y. Alright, so here I have my first step is to make sure these equations line up. So x's need to be lined up, y's need to be lined up, the equal signs need to be lined up, and the constants need to be lined up. So I want to get a couple of vocabulary things straight here. First off, the constants, these are the numbers that are by themselves. Those are constants. I'm going to erase those in a moment. And then the numbers in front of the variables, so the 8, the 3, the 6, and the -5, those are all my coefficients. So the number in front of the variables, those are your coefficients. Constants are the number that have no variables with them. Alright, so back to what we were talking about. We want to make sure everything is lined up. Equals, constants, all of it's lined up. If it's not, I need to do some manipulation to move it around or use a different method. The next thing I want to do, and this may or may not be necessary, is to multiply one or both equations by a number to make sure I've got opposite coefficients. So opposite coefficients would be like a -2x and a positive 2x. So a -5 and a positive 5, which I don't have here. I have a -5 and a 6, and a 3 and an 8. So then I want to check if there's anything I can multiply -5 by to get 6, or just 5. I'm going to ignore the negative for now, a whole number. And there's not. There's nothing I can multiply 3 by to get 8. That's going to be a whole number. So what I have to do is I have to multiply both equations by something. The easiest way to do this is to determine what you want to get rid of first, the y's or the x's. In this case, I'm going to go ahead and go with the x's. So what I'm going to do, I'm going to take the coefficient 6, and I'm going to multiply the entire first equation by 6. So I'm going to write that over here. So 6 times -5x plus 3y equals 31. And then I'm going to take 5, and I'm going to multiply it by the other equation. So 5 times 6x plus 8y equals 44. The question came up in class, shouldn't I make one of those negatives, or negative? And that's a really good question. In this case, I don't need to make either of these negative, because if I multiply this out, I've got 6 times -5, which will give me -30. And then I've got 5 times 6, which will give me +30. And I need those to be opposites to eliminate them. So I'm going to arrow this over and actually do, and change colors. Do the multiplication. So negative 30x plus 18y equals 186. Down here, I've got positive 30x plus 40y equals 220. And I'm going to, on step 3 here, so in terms of what steps are what, this is step 2. This is step 3 right here when I add the equations together. So 30x plus negative 30 gives me 0. That's how that gets eliminated. 18y plus 40y is going to give me 58y. And 186 plus 220 gives me 406. So now I have a pretty simple equation to deal with. So I can just divide by 58. And y equals 7. So that's one of my answers. Step 4 is the same as the other methods. I'm going to pick one of my equations and erase some of this writing around here. Pick one of my equations, doesn't really matter which. I'm going to go with the second one to plug in y and then solve for x. So this is step 4. So 6x plus 8 times 7 instead of y, because I know y equals 7, equals 44. 6x plus 56 equals 44. Subtract 56. So I've got 6x equals negative 12. Divide by 6. And I have x equals negative 2. So my answer, negative 2, 7. So that is a pretty quick overview of solving linear systems. Something to remember in the elimination method. Step 1, making sure everything's lined up. You can manipulate the equations to line things up. Step 2 may not be necessary, or it may only be necessary with one of the equations. And then step 3 and 4 are what they are. So,